Good evening and welcome to the South Downs Planetarium in Chichester. During the long periods of lockdown, many people have found that taking up an interest in nature or the natural world in general has helped them to cope with anxiety and stress. Indeed, many studies have demonstrated the positive effects of the natural world on our mental health at this time. This has led many people to take up an interest in the night sky. But during lockdown, when we all have to stay home, it's not possible to travel out into the countryside to find a really clear, dark site from which to view the stars. So we decided that we would bring the night sky to you, right into your homes, using our magnificent star projector here to take you on a guided tour of the winter night sky. Many of the objects I should be describing you can see for yourselves just by looking out of a window, but remember to turn all the lights off in the room first, or from your front or back garden, wherever you can get the best view. Because we project the stars and other objects in the night sky onto the inside of this big hemispherical dome, we've had to split our tour into two halves. First, we shall take a look at the northern sky, and then we should turn our attention to the south. Also, in this tour, we should be taking an in-depth look at the red planet Mars, which is also on view at the present time. So I just need to make my way over now to the control console of our star projector, and we can get started. We begin our journey looking north. It's 7 o'clock in the evening, and this is the view you might see on a clear, cloudless winter's night from the middle of a small town or perhaps an urban fringe area. From such places, there's always a certain amount of light pollution, particularly sky glow, which is the yellowish glow you get in the sky caused by artificial light that goes up into the sky and is then scattered by particles in the atmosphere. This reduces the number of stars you can see, but it's still possible to make out the brighter stars and the most important of the star patterns, even from urban areas. If, however, you live in the countryside or a more rural area, you may be lucky enough to have really clear, dark skies. So let's see the difference it makes between the sky that you can see from a small town to the sky you can see from the countryside. As you can see, it makes quite a difference. Many of the fainter stars that couldn't be seen before because they were lost in the glow of the lights are now clearly visible. It's now possible, seeing those fainter stars, to be able to make out all of the principal star patterns, or constellations as we call them. Looking north at this time of year, the star pattern which we're going to begin with is one that nearly everybody knows. We call it the Plough. The North Americans call it the Big Dipper. It's basically shaped like a saucepan, and at this time of year, in the early evening, the Plough is coming up in the northeastern sky. I'm circling the pattern of the Plough here. You can see there are 7 main stars in that saucepan shape. Here's the bowl, and there's the handle. Now, these stars are actually part of a constellation called the Great Bear. The Plough itself is not a constellation, it's part of one. So technically, the Plough is what we call an asterism, a group of stars that makes an obvious shape, but isn't a constellation on its own. The Great Bear actually contains a lot more stars than just those 7 main ones. The head of the bear is over here. Her front paws, her back paws and back legs. So the Great Bear actually covers quite a large area of the sky, with the bowl of the Plough being the rear of the Great Bear's body and the handle of the Plough being the bear's tail. Now, in mythology, the Great Bear goes back to the time of the ancient Greeks. 48 of our constellations were named by the Greeks and appeared in a publication called the Almagest, produced by the great astronomer Claudius Ptolemaeus, or Ptolemy for short, in about 150 AD. The Great Bear is one of those 48 original constellations. Now you can find the pattern of the Little Bear, or Little Dipper as it's sometimes called, by using the stars of the plough as a signpost. So here we have our saucepan shape. The two stars at the top of the bowl, Merak and Dupe, are often called the pointers because if you take a line from those two, we come to this star here. It's a very famous star, the North Pole star Polaris, and it marks the end of the Little Bear's tail. You can see the faint line of stars here and the box shape at the bottom. That's the Little Bear. Now I have an outline for the Little Bear, so let's see what that's like. You can see that the Little Bear here has a long bushy tail. It looks a bit like a squirrel to me. Polaris, the North Pole star, is not a particularly bright star. Some people think it's one of the brightest in the sky, but it isn't. However, it is a very important star because it's the nearest naked eye star to the North Pole of the sky, marked here by the tip of that white arrow. Now you can see that Polaris is not precisely at the North Pole of the sky. It's about half a degree away. In fact, the North Pole of the sky, the tip of the white arrow, is on the plough side of Polaris. The constellation of Draco the Dragon is a long and winding line of stars, so let me trace it out. The head of the dragon here is a quadrilateral of stars, and then we have the dragon's neck and shoulders, its back and its long tail. The dragon's tail is this line of faint stars in between the plough and the Little Bear. You can imagine it breathing fire from its mouth just like this. The Great Bear, Ursa Major in Latin, the Little Bear, Ursa Minor, and Draco are all original constellations from the 48 listed by Ptolemy. Now if we go from the pointers in the plough and on through the pole star to the other side, we come to another very well-known pattern of stars. It's shaped like a letter M that's been sat on, or a letter W, depending on which way you look at it. It is Cassiopeia, another of Ptolemy's original patterns. Cassiopeia was a proud and boastful queen, and is a very distinctive pattern, high up in the northwest at this time of the year in the early evening. You should have no trouble finding it on the opposite side of the pole to the plough. Cassiopeia is one member of our celestial royal family. We have Queen Cassiopeia, and then we have her husband King Cepheus. Cepheus is a rather difficult pattern to make out. It comprises a faint box of stars with a triangle on the top. I always think it looks a bit like a house with a high pointy roof. You might say, well, I can't really see the shape of a king in that, but actually this is supposed to be the throne on which the king is sitting. Cepheus is certainly nowhere near as obvious as his wife the queen, but may be found below and to the right of Cassiopeia as we look at it here. Then we have their beautiful daughter, the Princess Andromeda. This star, Alpheratz, marks her head, and then we have this very long, narrow, curving V shape of stars, which is the pattern of Andromeda, with her head, her arms, her waist and her legs. Here you can see the outline of the beautiful Andromeda. I'm afraid that I don't have outlines for all the constellations, just one or two of them. So there we have Andromeda, the beautiful daughter of the king and queen, making up our celestial royal family. You will notice just here, to the right of Andromeda's waist, that little elongated smudge of light in the sky. That is the Andromeda Galaxy, the furthest thing you can see with the unaided human eye on a really clear, dark night. We live in a galaxy, the Milky Way, and its stars are all around us. Andromeda is the nearest large galaxy to our own Milky Way. It's a great star system, a spiral galaxy containing billions of stars just like our own Milky Way. Of the remaining constellations we have in the north, down here we have the top of Cygnus the Swan. At this time of year, in the early evening, we can only see the wings and the tail of the swan. Most of the neck and the beak are below the horizon. We are looking here at the northern sky in winter, as it would appear at 7 o'clock in the evening. But the Earth is spinning on its axis, and this causes our view of the sky to change gradually during the course of the evening. Over time, the northern stars and constellation patterns appear to be revolving slowly around the north pole of the sky. Polaris, so close to the pole, hardly moves at all, but the Plough will rise higher up in the northeast, while Cassiopeia will sink lower down in the northwest. When learning one's way around the night sky, it is important to understand how the stars appear to move over time. Well, we're now going to turn our attention to the southern part of the sky. Now we've turned to face towards the south at 7 o'clock in the evening. Once again, we're going to start by looking at the view from the middle of a small town or perhaps an urban fringe area. So we've got some light pollution, reducing the total number of stars we can see, but even from such a place, the southern sky at this time of year is magnificent. The winter stars are a terrific sight even from a light polluted location, and because we have some easy to find star patterns, it's not too difficult to find our way around. First and foremost, we have Orion the Hunter and Sirius the Dog Star, the brightest star in the night sky, and then all of the well-known star patterns around Orion. Many of their stars are quite bright, so they can be seen even in a light-polluted sky. We also have the red planet Mars visible at the moment, which is always good to see, and a lovely 6-day-old moon slightly to the west and below Mars. Here is a lovely image of the 6-day-old moon taken by Nick James. When the Elizabethan astronomer Thomas Harriot made the very first ever drawing of the moon through a telescope on the 26th of July 1609, it was at a similar phase to this view. Tomorrow evening, the first quarter or half moon will appear much closer to Mars in the sky, and the moon will become more and more obvious during the coming week or so as it approaches full moon. Orion has many fairly bright stars and is a great signpost to help us find our way around. Here's Orion the Hunter with its 4 main stars and the 3 stars of Orion's belt that point down to Sirius the Dog Star. All around Orion there are more bright stars, so we'll start with Sirius, the brightest star in the big dog, Canis Major. Then we've got Procyon, brightest star in the little dog, Canis Minor. The twins of Gemini, Castor and Pollux. Capella in Auriga the Charioteer, virtually overhead. Then down to Aldebaran, one of the eyes of Taurus the Bull, and on to Rigel, the bottom right star of Orion as we see it, and back to Sirius again. Those bright stars make up an asterism called the winter hexagon, and it includes all of the most obvious stars in the area around Orion. But now we're going to imagine that we are transporting ourselves from an urban fringe location to a nice dark countryside site. What a magnificent view we have now! To link this view of the southern sky with what we talked about earlier, I just want to draw your attention again to Cassiopeia the Queen, appearing here more like a letter W and high up in the western sky. We saw her when we were looking north, and now we're also seeing her at the edge of our view. We've also got the Andromeda Galaxy there that we mentioned earlier, just below Cassiopeia. Moving to the left of Cassiopeia, you can see there's a long line of stars here and another there, which together look like the shape of an upside down letter Y. This is the constellation of Perseus, the great warrior and hero of Greek legend who was involved in many adventures. In between the small triangle of stars at the top of Perseus and the W of Cassiopeia, you may just notice a faint misty patch. With good eyesight, you'll see two misty patches very close together. That is a beautiful pair of open star clusters, the double cluster in Perseus, also known as the sword handle. It is a fine sight in a low-power rich field telescope. If we follow the line of stars in Perseus downwards, we eventually come to one of the most magnificent of all open star clusters, the Pleiades or Seven Sisters. We say the Seven Sisters because most people can make out 7 stars on a clear dark night with the naked eye. With binoculars or a small telescope you will see many more. They are all blue-white in colour. Now the 7 sisters are part of the constellation of Taurus the Bull. The head of the bull is this V-shaped cluster of stars known as the Hyades, with the red star Aldebaran marking one of the bull's eyes. The Hyades is an older and more scattered cluster than the Pleiades. Then we've got the horns of the bull, one of which goes out here and the other goes out here. The stars at the end of the horns are Beta Tauri there and Zeta Tauri there. If we add in the outline of Taurus the Bull, you can see it is a magnificent pattern. I mentioned earlier the bright star Capella, which is virtually overhead in the early evening at this time of year. It's a yellowish star, the 6th brightest star in the night sky. Capella is part of the constellation of Auriga the Charioteer. It's a sort of 5-sided box shape like this. You can see it doesn't really look much like a man driving a chariot, or indeed a man looking after a herd of goats, which is what some of the legends say. Then we come down to Orion the Hunter. This magnificent grouping contains 4 stars in a sort of a rectangle shape, with the 3 stars of Orion's belt diagonally across the middle. Here we see the outline of Orion superimposed on the main stars. All of those main stars have names. Betelgeuse, top left, Bellatrix, top right, Rigel, lower right, and Saiph, lower left. The 3 stars of Orion's belt are in order Mintaka, Al-Nilam, and Al-Natak. The sword of Orion curves down below the belt, and near the tip of the sword, just there, you can see a faint misty patch. That is the Orion Nebula, a stellar nursery, a glowing cloud of gas and dust inside which new stars and new planets are being born right now. Orion is one of the few star patterns that really does look like the character it is supposed to be. Above the stars marking his shoulders, his head is here, and in his right arm he is holding a wooden club, and over his left arm is draped the skin of an animal that he's killed. The 3 stars of the belt point down to Sirius, the brightest star in the night sky, a beautiful blue-white star. When we were looking at the northern sky, we used the plough as a signpost to help us find other star patterns. Now we're looking at the southern sky, the stars of Orion can be used in the same way. The 3 stars in Orion's belt point down to Sirius the dog star in the constellation of Canis Major, the big dog, which is always rather low down from this country. If you take the 3 stars of Orion's belt and go the other way, you come to Aldebaran, one of the eyes of Taurus the Bull and the V-shaped Hyades cluster. Extend that line onwards and you come to the 7 sisters. Then if you take the right-hand star in the belt and go up through Betelgeuse, you come to Gemini the twins, with its 2 bright stars, Castor and Pollux. Pollux is definitely the brighter of the 2. You can imagine the 2 heavenly twins lying side by side, a bit like 2 matchstick men. Head, body, feet and arms for the upper twin Castor, head, body, feet and arms for Pollux. The bright star here, which is sort of in between Gemini and Sirius, is Procyon in Canis Minor, the little dog. Betelgeuse and Rigel, at opposite corners of the main pattern of Orion, have very contrasting colours. Betelgeuse is orangey red, while Rigel is blue-white. Betelgeuse is a red supergiant star, a star so huge that if it was dropped into the middle of our solar system, its outer layers would stretch out to the orbit of the planet Jupiter. Rigel, a blue-white supergiant star, is the brightest of Orion's stars, ranked 7th brightest in the night sky. If you look at the Orion Nebula through a telescope, it appears as a faint, misty patch. Images of it will show lots of colour, mainly red, but if you look at it with the naked eye through a telescope, it will just look greyish, because our eyes don't see colour when the light level is low. The red planet Mars is on the border of Aries and Taurus, moving slowly eastwards. Over a period of a week or so, you'll notice that motion. Mars was at its best last year in the autumn, and it's faded considerably since then as its distance from the Earth has increased, but it's still worth a look. Its orangey red colour will be quite obvious in binoculars or a small telescope. Here is a lovely image of Mars taken by Damien Peach on the 5th of November 2020. This is a typical telescopic view, showing the pinkish disk with greyish markings, the shrinking south polar ice cap at the bottom, and some haze over the north polar region. As Mars spins on its axis, the surface markings appear to move across the disk, as you can see in these two images by Damien taken on the 11th of November, about 2 hours apart. In the centre of the left-hand image we have a prominent dark feature called Syrtis Major, extending upwards towards the north polar region. In 2 hours, Mars has rotated so that Syrtis Major has moved towards the right. The rotation period of Mars is 24 hours 37 minutes, so it's only slightly longer than the length of the day on Earth. Now, the orbit of Mars, in red here, is more elliptical than the orbit of Earth, shown here in blue. Earth takes 365¼ days to complete one orbit, whereas Mars takes 687 days. This means that Mars is best seen from Earth roughly every 25 months, so Mars is only well placed for viewing every other year. In the autumn of 2020, Mars was very well placed when it came to opposition, as we say, but in 2019 and 2021 it is not so favourable. The greater eccentricity of Mars's orbit round the Sun means that when it is at opposition, its distance from Earth varies. It may be as close as 35 million miles or as far away as 63 million miles. The varying distance of Mars at opposition means that the apparent size of the disk as viewed from Earth also changes from one opposition to the next. You can see here that in 2003 Mars was at its best. We call this a perihelic opposition, and only slightly less favourable in 2001 and 2005. In 2018, Mars was very similar to the way it was in 2003, and in 2020 comparable with 2005, so fairly well placed for observation. This cloud-free mosaic of Mars shows the main surface features. The planet's surface may be divided into two broadly distinct regions. The north, smoothed by the flow of lava plains, has the younger surface. The south is more rugged, heavily cratered from ancient impacts. Roughly marking the divide, across the centre here, is the Great Rift of Mariner Valley, the largest geological fault in the solar system. To the left of the disk you can see a line of three dark oval features. These are three of Mars's enormous shield volcanoes, Arsia Mons, Pavonis Mons and Ascrius Mons, summits rising over 10 miles above the surrounding plains. Here is a coloured contour map of Mars. The highest points are in white and red, and the deepest parts in purple and blue. Lower right, there is a roughly circular purple area, which is the deepest part of Mars. It is the Hellas Basin, a giant ancient impact structure. Much of the northern hemisphere, coloured blue, is flat and low-lying. To the left there is a large reddish area known as Tharsis, a region where molten rock welled up from below billions of years ago, creating a bulge in the surface. Atop this bulge, and pinpointed in white, are Mars's largest volcanoes. To the left of the line of 3 that we saw earlier, on its own, is the peak of Olympus Mons. To the right of Tharsis is the huge canyon system of Mariner Valley. So here we're looking down on the summit of Olympus Mons, the greatest volcano in the solar system. Rimmed by cliffs that are 4 miles high and measuring 375 miles across, its summit rises 16 miles above the surface. The summit crater, or caldera, measures 60 miles by about 40 miles, and there were many episodes of eruptions in ancient times. We don't know when this volcano last erupted, but it must have been spectacular when it did. This is Mariner Valley, a great rift or split in the crust of Mars that stretches 2,500 miles from one end to the other, the width of the continental United States. At a maximum 4 miles deep and 400 miles wide, this is the grandest of all canyon systems. The atmosphere on Mars, which is mainly carbon dioxide, is very, very thin. At Earth's surface, the average pressure is about 1,000 millibars, whereas on Mars it is only 7 millibars. In that thin atmosphere there are wispy white clouds made of water ice crystals, and you may also get yellowish dust clouds. Towards the left there are white clouds around the summits of Mars's 4 great volcanoes. Here is the surface of Mars, a region known as Ares Vallis, which was explored by Mars Pathfinder's Sojourner rover in 1997. It's dry, dusty, rocky and windy. The sky is pinkish because of dust suspended in the atmosphere. Even on the warmest days, temperatures barely top 0, and at night it can drop to minus 80 degrees C or below. In such a bitterly cold, dry landscape with a very thin atmosphere, there is no running water on the surface of Mars, but there is an abundance of water ice. This is the North Polar ice cap in winter. It can be as much as 3 miles thick. It's mainly water ice with a dusting of carbon dioxide ice, dry ice, on top. There's also abundant ice in the form of permafrost beneath the surface dust layer around both poles. Although we don't see running water on the surface of Mars today, we know there was a lot of water early in Mars's history several billion years ago. Today, in images taken from orbit, we can see there was once abundant water on the surface of Mars. To the left, we see channels formed by running water. To the right, we see where floodwaters coursed across the surface, carving out teardrop-shaped islands. So we have this amazing scenario where Mars today is a dry, dusty, frozen world, but long ago it was warmer and wetter. The atmosphere was denser, we believe, and there were rivers, lakes, perhaps even small seas on the surface. Maybe some form of microbial life tried to gain a foothold at that time. So we are very interested in the astrobiology of Mars and to try and find evidence of ancient Martian life. In August 2012, the largest and heaviest rover to land on Mars at that time, Curiosity, successfully touched down on Mars thanks to this ingenious sky crane arrangement which lowered the craft onto the surface in the final moments. This is where Curiosity landed, in the 96-mile diameter Gale crater, well within its targeted landing ellipse seen below left of centre. Mount Sharp in the centre rises about 3.5 miles above the floor of Gale crater. Curiosity has been exploring this region for the past 8.5 years. In this time, Curiosity discovered remnants of ancient stream beds in the crater. It found that ancient Mars had the right chemistry to support living microbes, and it found carbon in several samples drilled from Mount Sharp and the surrounding plains. It also confirmed that there was a thicker atmosphere and more water in the past. Now we have entered an exciting new phase in Martian exploration. In July 2020, 3 new spacecraft headed off towards Mars, demonstrating that the exploration of the red planet is now a truly multinational affair. First to arrive was the United Arab Emirates HOPE spacecraft, which successfully entered orbit around Mars on the 9th of February. It will spend the next 2 years carefully studying Mars's atmosphere to help us understand how, over billions of years, Mars gradually lost a denser atmosphere that could sustain liquid water on its surface, transforming the planet into the cold, dry world we see today. Next to arrive was China's Tianwen-1 spacecraft, seen here blasting off from Earth, and which successfully entered Martian orbit on the 10th of February. It will study the planet for several months before dropping a lander that will carry a robot rover to the surface. But the lander won't descend until May. You can see the rover here sitting on top of the lander and the ramps down which the rover will eventually descend. The third craft to arrive at Mars is the Perseverance rover, launched by the United States on the 30th of July last year. Here is an impression of Perseverance on the surface of Mars, the largest, heaviest, cleanest and most sophisticated 6-wheeled robotic geologist ever launched into space. It will search for signs of ancient life and collect samples that will eventually be returned to Earth. Let's see where it is going to land. Here we see the landing sites of some previous American landers on Mars. Perseverance is coming down near that prominent dark feature, which is the Syrtis Major that we talked about earlier. The target for Perseverance is Jezero Crater, a site selected from over 60 possible candidates. Jezero Crater is the circular feature towards the bottom right of the image here. It is a perfect place to search for signs of ancient microbial life. Billions of years ago, this now bone-dry 28-mile-wide crater was home to an actively forming river delta and a lake filled with water. Let's zoom into it. Jezero Crater, seen here in false colour, was once a deep ancient lake. You can see the crater floor in light blue and the curving walls of the crater, which in places are about 1,600 feet high, picked out in a reddish colour on the left side. Also on the left, at the 9 o'clock position, an ancient river flowed into the crater through a breach in the crater wall, and you can also see, top right, an outflow channel from the crater. This means that the crater must at one time have been completely full of water, and as water continued to flow in, it overflowed into the outflow channel on the right. Let's see why this is such a great place for Perseverance to explore.
Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
Here in close-up, we see that branching delta that formed in Jezero crater from the mud, silt and other flows brought down by the inflowing river through the breach in the crater wall and fanning out onto the crater floor. It is in these deposits that we might find evidence of ancient microbial life. While most of Perseverance's 7 science instruments are geared toward learning more about the planet's geology and astrobiology, the mission also carries technologies focused on future Mars exploration. One device will demonstrate that converting Martian carbon dioxide into oxygen is possible. This could be very important for future human exploration of Mars. The Terrain Relative Navigation System will help the rover to avoid potential hazards. Other instruments will gather data during the craft's descent through the Martian atmosphere. This will help engineers design future systems that can land more safely and with larger payloads. The rover also carries a passenger to Mars, another technology demonstration, the Ingenuity Mars helicopter, the first aircraft designed to fly on another planet. But it wasn't even certain they could build a craft that could fly on Mars.
Can we fly at Mars? That has been a question for a long time. This is a huge milestone for us. But really our job isn't done until we see the same test flight being performed at Mars.
Between 30 and 90 days into the rover's mission, Ingenuity will make its first test flight on Mars. And if that initial flight is successful, then it will make up to 4 more flights. Remember, these flights are to test the technology, to see if this sort of craft can fly on Mars. And if it does, it will give us a completely new way of exploring Mars, not just on the surface, but flying above it to provide a bird's eye view of features on Mars. So let's look at how Perseverance will conduct its exploration of Jezero Crater.
This flyover was produced from NASA images taken from orbit. The blue circle indicates the area the rover will likely land. The arcing hills in the center, about 1,600 feet high, and are the rim of Jezero Crater. The central goal of Mars 2020 is to learn whether life ever existed on Mars. It's too cold and dry for life to exist on the Martian surface today. But after Jezero Crater formed billions of years ago, water filled it to form a deep lake, about the same size as Lake Tahoe. Eventually, as Mars climate changed, Lake Jezero dried up, and surface water disappeared from the planet. An ancient lake is a fantastic place to pursue our goal of looking for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is often preserved in the mud and sand deposited on the bottom of the lake. So, we use the rover's instruments to explore the rocks of the ancient lake bed. Here we can see evidence of the former lake. The canyon cutting through the crater rim was carved by a river. As the water entered the lake, it slowed and dropped the sand and mud it was carrying to form the fan-shaped delta. The white line is a path the rover might follow in its first 2 years, called the prime mission. During this period, we use the rover science instruments to analyze the lake sediments. After we explore the delta, we hope to investigate the shoreline of the former lake. To get there, we have to traverse around a sea of modern sand dunes. From this perspective, you can see former shorelines curving around a headland. We can picture waves in Lake Jezero beating on a sandy beach. And finally, we will press on to the crater rim. Jezero Crater formed when a large object collided with Mars, excavating rocks from deep in the Martian crust, exposing them in the rim for us to study. These rocks would have been hot shortly after the impact and may have hosted hot springs. Deposits from these springs would be another target in our search for possible ancient life on Mars.
But all of this depends on a successful landing on Mars on the 18th of February, the crucial final phase of its 293 million mile journey from Earth, the so-called 7 minutes of terror, the time it takes from first hitting the Martian atmosphere at between 12,000 and 13,000 miles an hour to eventual touchdown on the surface. Hundreds of critical events must execute perfectly and exactly on time for the rover to land on Mars safely, including deployment of the biggest supersonic parachute ever sent to another planet. The parachute and powered descent slow the rover down to about 2 miles an hour, and then a large sky crane will lower the rover on 3 bridle cords to land softly on 6 wheels. Landing on Mars is very hard. It's going to be a nail-biting ride. Well, after all that excitement, let's return to the winter night sky looking south. This view of the southern sky is what you'll see at 7 o'clock in the evening. As the Earth spins on its axis from west to east, carrying you, the observer, around with it, the stars slowly appear to move in the opposite direction from east to west. Here in the planetarium we can speed up time. So now you can see how our view gradually changes as we move through the evening from 7 p.m. to 10 p.m. Over a period of 3 hours, the constellations move round quite a bit. So if you're learning your way around the night sky, it is important to understand how what you see slowly changes as time passes. Our journey through the winter night sky and our in-depth look at the red planet Mars has now come to an end. I hope you enjoyed the show. Most importantly, I hope you've been inspired to learn more about the stars, the planets, and the amazing wonders of the universe in which we live. Good night.